today we're going to talk about oxidation reduction reactions. When I refer to oxidation reduction reactions from now on, you'll probably only hear me refer to it as a redox reaction. That's really a common way to refer to these reactions. Redox reactions are reactions where electrons are being transferred between reactants. So what does that mean then? Electrons are being transferred. Where do those terms oxidation and reduction come from? Well, we use the acronym oil rig to help us remember what happens in oxidation and reduction. Oxidation is loss of electrons, reduction is gain of electrons. So by using that acronym, we can remember oil rig, how to determine what's happening to the electrons in both of those processes. Now keep in mind that the processes always occur simultaneously. You have to have something losing electrons in order for something else to gain electrons. And you can't gain electrons unless something's losing electrons, so they must occur simultaneously. So if we have oxidation, which again is the loss of electrons, keep in mind that those electrons are little negative particles, and since we're losing them, what happens is we're going to get more positive in oxidation number. So the oxidation number rises. Reduction, on the other hand, is, since it is the gain of electrons, and once again, those electrons are negative, the more electrons we gain, the more negative that species is going to become, the oxidation number is going to lower. So we're going to be able to recognize which substances are undergoing those two processes based on what's happening to their oxidation number. Now these last two terms, oxidizing agent and reducing agent, they don't use an AP, they say. They're not going to use them anymore, but that you find them so much in textbooks, I feel that we must at least cover them. And it's just kind of it's a word thing. The reducing agent is a substance that's causing something else to be reduced. So it's causing something else to be reduced because it's the substance that's being oxidized. So it is losing electrons so something else can gain electrons. The oxidizing agent is causing something else to be reduced. Excuse me, it's causing something else to be oxidized. The reason it can cause something else to lose electrons is because it itself is gaining those electrons, more or less grabbing them away. So once you find out the substances that are being oxidized, all you have to do is say, okay, if it's being oxidized, it's the reducing agent. If it's being reduced, it's the oxidizing agent. Those terms go together. So on your worksheet, the first thing that you're asked to do is to determine whether something is a redox reaction or not. And if it's not, you're going to put an X in front of it in the blank. And if it is a redox reaction, you're going to show what substances are being oxidized and what are being reduced. So in this particular case, we've got hydrogen +1. We're going to find these oxidation numbers. Chlorine -1. Sodium's +1. Oxygen's -2. Hydrogen's a -1. Excuse me, hydrogen's a +1. Over on the other side, sodium's +1. Chlorine's -1. Hydrogen +1, oxygen -2. So if you look through this, you'll notice that hydrogens are +1 over here and +1 over here. Chlorines are -1 on both sides. Sodium's +1 on both sides. Oxygen -2 on both sides. So nothing's changing charge. Since nothing is changing in oxidation number, that means there's not anything that has transferred electrons. So this is going to be an X as far as redox reactions are concerned. It's not 1. So then let's look at the next one. Magnesium, 0. It's a free element. Sulfur, 0. And if you need any help remembering how to do these oxidation numbers, please look at the previous set of notes. It's 2-1 over assigning these oxidation numbers. I'm rushing through it today because we've already had those notes and already done an assignment over it. Magnesium sulfide, on the other hand, has a +2 for magnesium, and sulfur is a -2. It's a binary ionic compound, so sulfur has a -2 charge. It's a chalcogen. So now what we have to do is to determine what's being oxidized and what's being reduced. So I'm going to want to figure out the substance oxidized, the substance reduced. I want to know the oxidizing agent and the reducing agent. Now that I know that something's going on here, I want to know all of those things. I'm going to draw an arrow, and the way I want this to look, I always find oxidation first, the thing that's the species that's increasing or going up in oxidation number. And I show that by drawing it from the left over to show that it's going from 0 to a positive 2. It's increasing in oxidation number. So magnesium is a substance being oxidized. I want you to put a little OX there. Sulfur, on the other hand, is going from 0 to negative 2. This is the substance being reduced. Now notice something. The substance oxidized and the substance reduced are always reactants. Those are the only possibilities. If it's a product, it's not the substance being oxidized or the substance being reduced. It's a product. So you only have two choices here. So the substance being reduced is sulfur. Now remember from our terms up above, if it's the substance being oxidized, it's called the reducing agent. So those will always be the same thing. If it's the substance reduced, then it's going to be called the oxidizing agent. Let's look at the next one. On the next one, arsenic is 0, hydrogen is 0. Over on this side, hydrogen, this is not a hydride because arsenic's not a metal. Hydrogen's still a +1 even though it's at the end. That gives a total charge, remember, of hydrogen of a +3, which means that arsenic is a -3 in order to get that to equal 0. So see if you can draw your oxidizing and reduction lines real quick on this. Pause it and see what you come up with. So hopefully if the substance oxidized, substance reduced, oxidizing agent, reducing agent. We have the substance oxidized in this case is going to be hydrogen. It's going from a 0 to a +1. So that's our substance oxidized. Arsenic, on the other hand, is going from 0 to a -3. There's our substance that's being reduced. So fill those in really quickly if you haven't already. And you should come up with the fact that hydrogen, make sure that you write it the same way it is in the net ionic compound. Hydrogen, H2, is being oxidized. Therefore, it's also the reducing agent. Arsenic is being reduced. Therefore, it is also the oxidizing agent. Whatever's being reduced is causing something else to be oxidized. So there's your answer for that one. For this final one, let's get the oxidation numbers for this. Potassium's +1 gives a total of +2 for potassium. Oxygen's -2, giving a -14 for oxygen, which means for this to equal out to 0, chromium has to be a +12. Well, if 2 chromiums are a +12, then 1 chromium's a +6. So there's our oxidation number breakdown for that compound. Water, as usual, +1 for hydrogen, -2 for oxygen. Sulfur, 0. Potassium, +1. Oxygen, -2. Hydrogen, +1. Chromium, in this case, remember if we have a 2-3 combination, we can cross charges. Chromium's +3, oxygen, -2. And in the last one, oxygen's -2. Total of a -6 for oxygen, which means sulfur in this compound has to be a +6. So see if you can draw your arrows to show what's being oxidized and reduced. So hopefully you came up with the fact that the substance being oxidized in this case had to be sulfur. Sulfur's going from a 0 to a +6. That's our substance oxidized. Whereas in the other compound, it's chromium being reduced. Chromium's going from a +6 down to a +3, so it's being reduced. Now, watch it on this one. This is where you're going to make your mistakes. Substance oxidized, substance reduced, oxidizing agent, reducing agent. You want to make sure they're in net ionic form when you write it down. So think about what's going to split. This is an ionic compound, so it's going to split or ionize here. The SO3 over on the other side is not going to ionize because it's already in, it's a molecular compound. Oxides don't oxidize. Sulfur, excuse me, don't ionize. Sulfur is a free element, so it's not going to be able to do anything. It's going to stay a free element. It's not going to ionize. So these are our two substances to work with in net ionic form. This is where you're going to mess up. This substance right here, we're going to write this down in our list over here as a polyatomic ion, net ionic equation form after it splits or ionizes. So the substance oxidized here is going to be sulfur, which means it is the reducing agent. Be careful here, the substance reduced, net ionic form, is going to be Cr2O7. Be careful. If it splits, it gets a charge. Don't forget that 2 minus. That's what's going to lose you points on this assignment if you forget that. And the substance reduced is also causing something else to be oxidized. It's the oxidizing agent.